Hey everyone, welcome to my channel. Yet again, I came with another interview preparation. This is right for persistent systems. So I'll share my screen. I have added some information to PT. Just a minute. I hide this, and after that, yeah, this is the next interview. So I added this. Okay, so more technical interview than level one. Persistent will expect so hands-on plus some depth plus perform solving mindset. Okay, problem solving mindset. So let's see. And it says, and I'm not sure like from where this data is getting, from where it is getting the data. I believe this is analysis whatever it done. So that's what I'm thinking, but I'm not sure. Let's see. So Spark, Big Data, Python, SQL, Data Engineering Design, Analytics, ML Awareness, Communication. So this is the expectations. So let's see. Tell me about yourself. I already um, said okay, but I'll redo one more time after reading this. Okay, I have extensive experience building scalable data pipelines for analytics in financial and enterprise domains. I have worked with Ibinitio and Spark based systems in just transform and mm, prepare large scale data sets for downstream reporting and analytics. I have designed data models and pipelines that support business use cases like billing, reconciliation, and risk analysis. Recently, I have also been working with PySpark, Python, and to enable more flexible and scalable data processing for advanced analytics use cases. My focus is on always in data quality, performance optimization, and building reliable systems that supports business decision making. Okay. Round two, Spark Deep. Most important question: how does Spark process data internally? That I'm perfectly aware. So whenever you execute something, it will create a logical plan that is a DAG, directed acyclic graph, that will be distributed and based on the shuffle. Like for example, if you have a grouping in the uh, any complex narrow wide transformations, then it'll distribute into different stages in the DAG level, and each and everything will be executed step by step, and after that, yeah, stages and tasks run and executors and transformations are lazy. So until an action triggers, it won't execute anything. Okay, what causes shuffle? Shuffle, any wide transformation will cause a shuffle. So since we are preparing in another chat window which is Spark Prep, so there are another list of videos on this line as well. I'm yet to complete few of them, but yeah, so it's not completed yet, but I'm still continuing the preparation. So you may able to see that channel, that chat window as well. Please try to explore my videos as much as you can. Okay, so uh, yeah, shuffle causes, yeah, of course, repartition distinct. Okay, this is the different operations, I mean, which will cause the shuffle, of course. And how do you optimize Spark jobs? So this is a good question. Optimizing Spark job. Mm, Combining multiple transformations in a one go, that can be possible. And if it is any reusable data set, then reusable data frame, then you need to persist that. That's also one of this. And apart from that, optimizing, mm, reusable code is the best way to to have a better readability. Better readability will create will give a great grip towards your program, whatever you are writing. Right, so the readability should be there. That's also one of the factor. Shuffle, if there is any possibility to avoid shuffle, try to avoid that. And any filters need to perform, do it as early as possible. If for joins, like only use those type of columns which are really needed, so those columns only you take. Okay. And you need to try the data should be in a good quality mode, like it should not have unnecessary values, nulls, anomalies, data anomalies. You just try to recognize those things. So in those way, in that way, if the data is perfect, the results will be perfect as well. So yeah, broadcast join, reduce shuffle. That is I said, prepare partitioning. Yeah, proper partitioning. Sorry, that is this I missed. Cache wisely. This is avoid UDFs. Okay, use columnar formats. Okay, data storage purpose, use columnar formats is the main intention it has given. Okay, let's see. I missed the broadcast join. Of course, join. I optimized the join. I said yeah, broadcast the join, reduce shuffle. I said, of course, and partitioning. I completely forgot. Since since Spark is a distributed computing environment, so you try to utilize maximum out of it. Don't keep any partition idle. Try to do as much as utilization of the environment. That is also one of the best criteria. Avoid UDFs. Yes, user defined functions we need to avoid. Mm, try to do use as much as predefined functions, inbuilt functions. That will give a better control. Okay, next, how do you use Python in data engineering? Pandas. One of the thing is pandas. Data transformation, ETL pipeline, API integration, data validation, Spark. Okay, data validation. What it has? I may need to check about it. Okay, just a minute. How Python do data validation? I know the data transformation. I know the ETL pipeline, but API ingestion, how it will do? How Python? How Python API ingestion integration? Sorry, API integration. What it has for API integration, I need to know. And of course, data validation. There are functions. Maybe I need to work on it. Of course, PySpark I already know. So as of now, these things. Okay. Explain list versus tuples. List is mutable, tuples are immutable. List with the square, you'll mention it square brackets, and the tuple is with the curved brackets. Okay. What is that? How do you optimize a query? Indexing. This area I am yet to work on. There is one more channel for this as well. I need to work on it, man. Come on. Okay, I'll try to improve that as well. Mm, Filter early, use join efficiently, analyze execution plan. Execution plan, I don't know. SQL execution plan. Okay. Difference between group by and window function. Group by, group the data and give a single record out of that particular group. But window function uh, will do cumulative summaries, like will accommodate as a new row. Keep the row level details, and it will attach the result as a new row, new column. Sorry, new column. Aggregate source, group by aggregate rows. Windows keep row level details as well. Big data concepts, Hadoop ecosystem. What is Hadoop ecosystem? Hadoop ecosystem is like it has few different functionalities, like HDFS is there, and you need to have a in the ecosystem for the compute. For the compute, I don't know what it can be. I have a file. I know it has a file system and a DB as well, like local file system as Hive. That it has. Hadoop ecosystem. What else it has? It's a big data environment where it can accommodate a huge amount of data, and the processing of the data. MapReduce is for processing, and Hive is SQL, of course. Spark, fast processing. Hadoop is storage, HDFS is storage, and MapReduce is a processing, and Hive is SQL. And fast processing you can incorporate with the Spark. Okay, that is also good. This is basic explanation it seems, but it has some more things. Maybe let's go further. As of now, around analytics, ML awareness. How does data engineering support machine learning? Clean data, feature engineering, historical data storage, data pipeline for model training. Data pipelines for model training. This I have aware, and of course cleansing data. How the cleaning of data is support is in machine learning, I don't know. I'm yet to check on that and future engineering. Of course, it is. You can in any environment the ML integration or any AI integration will always help you to thrive more, so that we need to understand as early as possible. Of course, next scenario question is what is the scenario question? Your Spark job is slow, what do you do? Spark job is slow. I think I'll go analyze the logs first, um, and incoming data, whether it is reading correctly or not. Is there any possibility while reading the data? Is there any data corruption happened? um, and I'll go to the DAG and the corresponding logs or Spark UI. It will that will provide where the process is running and at what stage it is, and what task it is currently running, and all those other information will be there. I'll observe those things, and if there is uh, any further information required, I'll go through the system logs as well, and I'll try to identify where it is stuck. So from there, I'll try to check Spark UI, identify shuffle, check partitions, optimize joins, check data skew. Check data skew is a performance tuning aspect actually. Data skew is performance tuning related, so I don't know why they given here, but I'll I'll, I'll try to learn that as well. Large data, partitioning, distributed processing, efficient formats, efficient storage formats. This may not. Okay. Incremental processing. Incremental processing will help you to whatever you already loaded, it won't do anything again, and just try to load which is not there in the target uh, location. So that's what is collaboration. What is this collaboration? Data scientists are the destination for us, like whatever the data scientists request the data, so we'll get requests from those data scientists, and we'll provide the data to them, so we are the source for them. So um, how do you work with means we'll try to understand the requirement actually, like end to end. For example, like they were telling about a particular product, and we'll try once we have a organizational level, if we have any mm, detailed information about our particular flow of our data pipeline, we'll obviously able to answer those questions, because they don't have much idea about the pipeline. They'll have an idea about the product and the data. I think so. Provide clean data sets, build feature pipelines, support model deployment. This is somehow is a gap, but let's see. High impact keywords, use this distributed processing, scalability, fault tolerance, partitioning, data quality, optimization, DAG and lazy evaluation. Okay, practice mode important. What is that? Simulate now. Okay, now explain how you would design big data pipeline using Spark for analytics. Okay, I'll answer this. Taking time. I don't know why it is taking time, but let's see. It's taking a lot of time. Yeah, Spark data pipeline. So I'll try to analyze what type of sources I'm gonna read. After that, is there any anomalies in the data? Data cleaning will do, and will do in such type of architecture mm, where I need to raw layer and the silver layer and gold layer the data of that particular. I'll differentiate the data in such a way, and each pipeline level. I'll try to do data cleansing most of the cases, and I'll try to just get the data quality of quality of the data as well, and in the transformation I'll try to optimize as much as I can, so that it can be a clean run. Try not to try to use the distributed aspect of Spark, where uh, if I utilize that distributed architecture, it will the performance of the job will be effective. So that's where I think optimizing the performance of the job. And after that, auditability is my one of the core strength. Like what feed we are receiving and what type of controls we are putting on top of it to 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 improve the quality, and how many records came, and is there any anomalies in the data, is there any issues in the data. All those things should be delivered as an email, so that everybody in the team should have an idea about those things. So that's the way I'll design, and of course I'll choose the better output formats, and like columnar formats, so that the read and write should be effective. So yeah, that's it. Yeah, articulation level, I feel still there is a gap. So that thing I'm thinking to work on. So let's see. I think there is some improvements it will suggest right now. So we'll analyze that, and we'll try to improve further. It'll take a lot of time, I believe. So let's go ahead and see the requirements one more time in a better. Okay, let's see it answers anything. It'll take a bit of time. So in between, let's try to the same thing. If I try with the Claude A, and what it will do, I'll just wanna cross check on that. And so let's see. So let's go to Claude A. Claude A. I have already created an account on it, and I'll try to put this description there, and let's see what it says. So I'm randomly asking something like this. So I'm still yet to figure out which type of GPT, which type of prompt I need to use. So, but as of now, I'm just typing this. I have interview. persistent systems. Please help me prepare for this. So let's see. We'll go back to the GPT and great. Okay, it gave some answers. So let's see. Good effort. You cover data quality, performance, distributed processing, and auditability, which is strong signals. But in the interview, this needs to be structured and clear and short. Okay, yeah, that I really know there is a gap in my articulation skills. I started. I started thinking, working on it. So I'll try to improve on those lines. Okay. I would design a pipeline in a. I'll read out the what GPT has given. I would design the pipeline in layers. First I ingest data from source system into a raw storage layer like S3 or HDFS. Then I use Spark for distributed processing. Okay, this is a good question and answer. Let me note it down. See, these type of questions, it will come in between and you need to note them down, otherwise you'll forget. Let's save this as well. Let me I think I need to. Hello, plain text format or normal text file, save as. Let me put it in the same window. Spark preparation, df, Spark preparation. Interview prep with AI. With AI question and Q&A. I'll just say Q&A. Q&A. Okay, let's see. Let me save it in such a way so that you know. So okay, so the question is straightforward. Explain how. Yeah, let's. It's taking a bit of a time to copy this as well. I don't know whether it is taking time for me or for anybody else. I'm not sure, but if anybody come across to understand this, you just let me know. Okay. So I would I would design a pipeline in layers. So even I thought once I faced this question, I thought in such a way that first source and the current environment perspective and the uh, features of the environment you need to use and the target. So this is the way I also thought. I think the thoughts are matching, but there are some articulations. Articulation is missing in those lines. So let's see. First I ingest data from uh, store systems into a raw storage layer like S3 or HDFS. Then I use Spark for distributed processing to clean, validate, and transform data, and apply data quality checks and business rules. I optimize transformations using partitioning and minimizing shuffle operations. Minimizing shuffle operation is the best thing to achieve in Spark environment. The process data is then stored in columnar formats like Parquet for efficient analytics. Additionally, I implement auditing and monitoring, including record counts and anomaly detection, to ensure reliability and transparency for downstream analytics. Okay, why this works means clean flow. The flow is pretty clean up. That is missing in my case. Show Spark knowledge, of course. Covers data quality audit. Very important. Yes, of course. And mention performance. Okay. So quick interview tip: ingestion, processing, optimization, storage, monitoring. Yeah. What is the difference between narrow transformation and wide transformation? Uh, Narrow transformations are those. Okay, I'll answer this only. Once we fix this, is irritating me actually. It's taking a lot of time to get the answer from audio. That's the biggest problem I have. I don't know how to fix it. Yeah, narrow transformations are those who does not involve shuffle, but wide transformations will involve shuffle. Narrow transformations like select, filter, these are the narrow transformations, and wide transformations are like joins, grouping functionalities. These are the wide transformations. Precise. Okay, fine. Hmm, okay. In Spark, narrow transformations are those where each partition depends on only one parent partition. Okay, so no data shuffle is required. Yeah, of course. Somehow we need to pick up this one simple way to explain this thing. So narrow, no shuffle fast, wide, shuffle slow. If once you set this to the interviewer and then after that you explain about it, I mean it will be very clear and very short, and will will be in line with the interviewer, I believe. But if there is any gap, you just please comment and let me know. Mm, Nowadays I don't know like whether interviewer expecting definition. Maybe they may say dependency concept and the shuffle mention. Of course I already mentioned in my answer as well. I think I did. Oh my god, it didn't capture everything. Transformations like select, filter, data transformations, and it didn't capture at all the entire information. Okay, that's fine. Going forward I'll try to check whether it is captured or not. Okay. Next question: what is shuffle? Why is shuffle expensive, and how do you reduce it? Let's wait. Let it come. Yeah, shuffle is little expensive as whenever you use the shuffle, um, it'll spill the data into disk and it will cause some disk space utilization issues, or else the memory. The Spark is a distributed computing environment, in in-memory computing environment. So if you occupy with the data, then it will cause some trouble. So that's why it is expensive. And when there is a possibility of a narrow transformations, use the narrow transformation irrespective. It's to avoid the shuffle, and if there is any filtration need to be done upfront, we can do that so that it will reduce the data, and that will also help in such in one way. And try to perform those type of operation where it have a less involvement of a shuffle, and try to combine the transformations, combine the actions, combine the transformations together, so that once the shuffle happen also it will perform both the operations together. So yeah, that's what I am saying right now. Let's see whether it is correct or not. Yeah, due to delay, it is. I'm not sure whether it is captured correctly or not. There is a drawback here. I think I need to explore another like Claude as well. Let's see what it will capture. I think it is captured everything, but let's see. Um, so what it has given now: mid-level 2 to 4. Python, Spark, Hadoop, Hive, SQL, Scala, no Scala, something else. If I click on something else, okay, something else I need to mention, I believe here. Okay, so what I have pinged and what it is answered. Let's see. See, this is a new way of learning we explored, I believe. So as of now, we used to deal with one AI only. I think let's try to include. I think this is Gemini. I'm not sure as of now, but yeah, let's try to include Gemini as well, so that uh, we can have a better understanding about that particular topic. So let's see. Let's say we issue next. What it is asking concept. What type of preparation do you want? Do you need most? Okay, it is asking inputs as well instead of it's figuring it out inputs in between. It's asking inputs as well. Concept, revision, coding, SQL practice, system design, and HR behavioral questions. All of those. And what else they may ask in the interview? It's okay. Let it be. As of now, we'll do this only. So, but voice here it is not there. It seems right. Voice model it's not there. Then if you need to keep on typing everything, then it will be a difficulty for us. So I think whatever we have here, we need to adjust as of now. But yeah, good effort. You cover data quality. No, no, this is something else. Okay. Oh, good. You mentioned spill, memory, filtering early, correct thinking. Now let's make it sharp. Interview. Perfect. Shuffle is expensive because it involves data movement across nodes, which causes network IO, disk IO. It didn't answer yet, I think. Let me refresh once. So this is the only drawback I have right now, but I don't know whether it is only for me, for anybody else. I'm yet to figure out that thing. What I want to do is I want to ask an example scenario. I'll ask the example. Hey GPT, give me an example for the above question you have mentioned, and the you fix the problem also, and let me know. I will go through that code, whatever you have given, and I'll try to reply the same in those lines. In between, let's see this thing. Okay. Uh, must know Hadoop architecture. I know the Hadoop architecture, of course. Hive QL, Hive query language. I have an idea. It worked in the past. Ab initio is your strength. Cooperating system GDE, of course. So so it is not asking any questions, or it is asking any questions. Let me see. I'll try to read those lines. Here is you. Here your complete interview prep hub. Click through each tab to explore topics, sample questions, and jump into deeper practice. Here is how to use this effectively in the time you have. Core tech revision. Okay, it gave a 5 day plan. Okay, which I don't want actually. I have interview within some time, so okay. So now, okay, absolutely. Let's make it concrete. Okay, why is shuffle expensive and how do you reduce it? Okay, below is a small PySpark example that first shows a shuffle heavy version, then a better version, and why and the way the fix helps. Okay, problem example is shuffle heavy code, which is transaction def, very large table, customer def, small lookup table, and we want to join them and then aggregate. Okay, so I think it might be they use direct to join first and after that broadcast. I feel like replace with broadcast maybe. Okay, so in that case, okay, let's see. It is mark session column. Uh, okay, Spark session builder app name shuffle example get or create. Of course, get or create the session. Spark session I'm creating, and after that transaction data so and so, and transaction df. Okay, I think join customer DF, transaction DF, customer DF. I think broadcast join can cause shuffle here and group by cause shuffle here. So this can be done, I think. So action is triggered and so it will start the process. And why this is expensive? Join may shuffle the data. Of course, group by cause the shuffle as well. Okay, what it is mentioned in the join spark may move rows across executors. So matching customer ID values meet on the same partition. Okay, group by causes shuffle. Of course, it all rows for the same segment must come together. That is correct. More data than needed is joined. Okay, this is a good question. We need to understand that. Mm, okay, let's see the answer. More than needed joined. Better version reduce shuffle cost. Okay, we improve in three ways. Filter early. Unnecessary unnecessary columns of data is not needed. So whatever the required columns for the current computation and the future computation is the main motive we need to worry about. So that's the way we need to work. So filter early and select only needed columns. Broadcast the small lookup that I know. Yeah, customer DFS broadcast. So broadcast will help you to copy that small table into each node so that it will be easily available to join them. So that's where it is. And of course the filter happens on. Okay, that's a good way of fixing this. Yeah, filter early. Amount is greater than 100. Okay, reduce the number of rows here. Okay, okay, select only. Filter the number of rows means you decreasing the number of rows here, and here you're decreasing the number of columns means you're just having those columns that are needed for current or future computations. Of course, that is then we improved broadcast join. Okay, which shuffle is removed. Okay, join shuffles is greatly reduced or avoided, but group by segment still needs to shuffle. Okay, still needs to suffer. Of course that needs to be shuffled, but what? So the goal is not remove all shuffle but reduce unnecessary shuffles. That's correct. How to verify in Spark? That's an explain plan. Yeah, optimize df dot explain true that will create. Okay, it's a good thing. Next, in the physical plan look for broadcast has join. Okay, and exchange indicate shuffle. Okay, this I'm yet to explore. One more common bad example. One more common bad example. Group by customer must brought together possible improvements. Filter early, reduce data before grouping. Use group partitioning strategy if reduce often. Okay, next, tiny memory trick. What is this tiny memory trick? Join group by repartition distinct, usually shuffles. Filter select, usually narrow or cheaper, of course. Mini check for you. What is that mini check? Filter so and so group by some amount. Which part is narrow and which part is wide? Filter is narrow and group by is wide. Filter is narrow and group by is wide. So let's go to Claude and we'll see how we can improve it now. Click through each tab to explore topics, sample questions, and jump into practice. This is asking about this one. Okay, for example, if I explain the topic, okay, it will write this. Okay, now I got it. Mhm. So the explanation, okay, Hadoop architecture, name node, secondary name node, data node, rack awareness, replication factor, uh, fault tolerance, due to replication factor, it is default replication factor is 3 and it will identify those things. Okay, fault tolerance mechanism may, okay, what it has given till that level, and after that it is asking a question now. With me to drill into Hive internals, yarn architecture, and for example, if I say yes, let's see what it answers. But meanwhile, it will go to this level. This is correct. Filter exactly distinct interviewers want. Okay, tiny reinforcement. Okay, rule of thumb. Okay, narrow. Each output partition depends on one parent partition. Wide data must move across partitions. Okay. Okay. Next, quick. Oh, this I think it's just explanation about the wide and narrow transformations here. What about join in Spark? Is it usually narrow or wide? Joins usually are wide. If you use broadcast, it will be narrow. It will be a bit narrow. Okay, I'll answer that and let's see. Joins are usually wide transformations. If you use broadcast, it might reduce the impact. It make it narrow maybe. Okay, something happened here. Okay, right. So let's see the other one. Hive internals, yarn architecture, life cycle, and if you keep on choosing like this, it will be okay. Let me skip it. As of now, let me skip it and I'll see. No preference, so it will give every answer or it will just give the minimalistic information, and I wanna see that. Join took as joins. I don't know. Let's see. Just said maybe. I think it might point out you were not confident enough. That's might. I'm just expecting like it might say that, but let's see. Okay, so joins is usually y transforms. That's a good question, good answer. Yeah, the second part is almost right, but let's sharpen it. Okay, let's sharpen it. Okay, correct way to say normal join usually wide because Spark often needs to shuffle data from both sides. Broadcast join still a join, but Spark avoids the large shuffle by sending the small table to recovery executor. Of course, that is correct. So joins are generally wide transforms because they require shuffle. But if one table is small, I can use a broadcast join to avoid the shuffle. So on the large data set and improve performance. Of course, important nuances. Do not say broadcast join becomes narrow to okay. It's not narrow, even though it is not. Okay. It reduces our avoid shuffle cost. It's a good answer. Simple matter mode, regular giant. Both sides may move. Broadcast giant, small side is copied. Big side stays mostly local. If DF2 is small, this is usually much faster. One small check. Which table should usually be broadcast? Small table, obviously. Okay, so yeah, this is small dimension table, small dimension table. That is the answer. Let's hope for the next question what it will say. Just a minute, I'll take 2 minutes break and I'll be back. I'm back. Sorry for the delay. Okay. Yeah, of course, it's related to memory. Okay, broadcast is small dimension table, so it's available on all executors, avoiding shuffle. Um, yeah, of course, don't run if it is too large. Okay, default threshold is 10 MB configurable. Memory issues, of course, always validate using execution plan. Quick final check. Last one before interview. No, if both tables are large, this case I think smart. Okay, let's see. I think Spark will. I think Spark will shuffle this, but both large table do not broadcast internally. Whatever the optimization needs to be performed, the Spark will perform that. Let's see the answer correct or not. So in between, let's continue with the Hadoop architecture here. Uh, okay. So here is a complete breakdown of HDFS architecture and fault tolerance. Exactly how you should explain in your interview. Okay, let's see. Big picture HDFS. Out of distributed file system designed around one core idea. Store enormous files across many uh, community machines and every design decision flows from that. There are two types of nodes. You must okay, name node and data node, obviously. Client application user. Okay, it will go to the name node. Name node will have a request to the data nodes, and of course, it will be replication factor is there, and the secondary name node to maintain this actually. Uh, hmm. Key components what interviewer wants to hear. Name node is a master and stores. This is the entire Hadoop architecture it has explained, and after that, fault tolerant mechanism will learn. Block replication, of course, this is a rack awareness checksum. Name node HA high availability. Okay, how it is achieving block replication and rack awareness. Block replication, I know default is 3, and it will replicate the um, data nodes. Let's go back to this question. Yes, that's the core idea. Clean interview answer. If both tables are large, Spark usually performs a shuffle join, where data from both sides redistributes across partitions based on the join key. Uh, Okay, the performance obviously depends on the join and just queue and join type. Uh, Slight correction in your wordings, both non-broadcast. Say both large tables will likely to be shuffled unless Spark can optimize differently. Okay. Check mental model. Small plus large, large plus large usually shuffles. Of course, this is I know. The final check. Which is more dangerous for performance in a large join? Shuffle itself or data skew? Shuffle. Shuffle only. Okay, data skew is okay. Unbalanced partitions. Data skew, unbalanced partition. One executor gets most of the data. Uh, okay. Okay, interview ready answer is shuffle is expensive, but the skew is the most dangerous because it creates uneven partitions where one task becomes a bottleneck and delays the entire job, of course. So, quick example is like in one particular key, 90% of the data is there. So then it will go to one partition, and that will take a lot of a time. So salting, key salting is the salting the key Salting the key, repartitioning, skew, join, handling, broadcast if applicable. Salting, you will add something, some salting number to a particular key, and you will redistribute it so that it will distribute. It will try to distribute it evenly. So there, it will help you to. Uh, yeah, that's a good question. Good. I forgot the salting aspect as well. Okay. Yeah. Skew optimization. Okay, these are the keywords. Okay, next, if you want, I can do 5 minute rapid fire. Yes, I got more questions to answer. Let's see. But I feel like the interview is minimalistic. It seems. I don't know exactly what happens in the actual interview. I'll say that. I mean, it's a lazy evolution on Spark until action. Until action, nothing will be triggered. Until action, nothing will be triggered. I think it will ask. I think it will say it to refine. Okay, next question. DAG, directed acyclic graph, which will help you to understand the execution plan. DAG will help you to understand the execution plan end to end, the stages and the corresponding tasks, so that for a better plan. Yeah, I'm still struggling with articulation. I don't know how to pick up, man. Come on. Articulation is still giving me a hard time, but let's see. Let's hope for the best. Okay, it's not at all captured anything. Okay, I'll say it's an hour interview. It's an hour interview with persistent. Uh, it's an hour interview with persistent. Read the JD again and try to give more questions. More questions. I'll say. Okay. I'm not sure whether it will give the perfect questions as of now, but if not, I'll try to stop the video recording now and I'll try to prepare from the again. You're right. Let's realign properly. Persistent is not testing only Spark basis. This JD is advanced analytics, Python, big data, problem solving, collaboration. So expect less textbook, more applied and scenario cross skilled questions. So if that is the case, then you have to ask that only. But why are you asking this? Okay. Next to data engineering, Spark plus Hadoop, Python, practical and object oriented programming, SQL, okay, ML awareness, data solutions for analytics. Most important question: how do you build a data solution for advanced analytics? This is the same question. It is reiterating again, but it's in a ML perspective right now. So, okay, expected answer structure is like ingest data, structured and unstructured, clean and validate data, feature engineering, store in analytics and ready format. Okay, enable ML reporting. Okay, Spark and plus analytics. How does Spark help in advanced analytics. Distributed processing, obviously, and handle larger datasets. ML support faster than Hadoop MapReduce, of course. Large datasets, of course, is another. Python D analytics. How do you use Python and for data processing, data cleaning, ETL pipeline, pandas, and for PySpark, and feature engineering and automation? The same. All the answers are looks like a similar notation based only. So I don't know how this gonna suffice the interview requirements. Let's see. Real scenario important is like we receive messy unstructured data. What do you do? Parse data, JSON log text, clean noise, validate fields, convert to structured format, store for analytics. Data conversion part. I think in the earlier interview today, I didn't mention about this. I believe. I think unstructured data came in actually. Parse data, clean noise. Clean. What is meant by clean noise here? Like maybe removing the unnecessary chunk values, or maybe I'll ask this question. Like, what is this chunk? Uh, Clean noise in. I think I can answer here only. Clean. Okay. Okay, fine. Let's see. SQL plus analytics. How do you parse data for analytics? Aggregation, joins, window functions, data normalization, machine learning awareness. How does data engineering supports ML? Clean data, feature engineering. Same things are repeating, man. I don't know. Historical data sets, data pipelines. Okay. Python object reusability, maintainability, modular design, scalable pipelines. Okay. Difference between Hadoop and Spark. Hadoop is disk based, Spark in memory. Problem solving, critical. Your data pipeline is failing randomly. What do you do? Check logs, validate data, check dependencies, retry logic, alerting, restartability. Yeah, I forgot about the restartability actually. In the okay, restartability collaboration. How do you work with data scientists? Provide clean data, build feature pipelines, support model deployment. That's the same again. Advanced. They may test depth. How do you handle large scale data, partitioning or distributed processing, efficient formats? Um, Incremental loads. How do you optimize Spark job? Broadcast, partitioning, okay, reduce shuffle, okay. Behavioral, very likely. Tell me about challenging problem you solved. Problem, action, result. Problem, action, result. How do you mentor team members? How do you handle ambiguity? Key differences. Just Spark basics not enough. End to end thinking. Only ETL, analytics mindset. Tool usage, problem solving, theory, real examples. Okay, final 1 hour strategy. Spark optimization, Python plus object oriented programming, ETL analytics, data pipeline, data quality validation, scenario based answers. Okay, last mock real question. How would you design a Python based data pipeline for analytics on large scale data? Uh, I think dictate is not at all working properly. I think we need to find a better settings to make it work dictate very well. I'll do the raw ingestion to the corresponding data layer using Python libraries, and after that, I'll try to find anomaly detection, and if there is any um, nullability checks and in business validations or business rules, those things I'll check, and after that I'll make the data ready for the analytics by avoiding unnecessary columns, and I'll segregate them in a proper way whether a business user can use for the analytics, and I'll choose a right target DB or right target file system so that it can in a columnar format I'll try to show so that I'll try to store so that the usage perspective also it will be very easy to handle, and after that I'll enable system like that to have a better auditability so that every feed whatever I received it needs to get the it needs to get an email notification with the details like how many files came, what is the data we have loaded, what is the record count we have loaded into the system, and as all those audit related stuff I'll try to add. And apart from that, if there is any restartability required once the job fails, I mean how it needs to be restarted and all those restartability aspect as well, I'll check and I'll try to implement the same. Let's see the answer. Let's see. So this much big answer I have given. I don't know how much time it will take to, you know. Let's see. Ingestion, validation, analytics, storage, audit, restartability, clean and sharp. The clean and sharp part itself is a problem now. Yeah. So final rapid fire. I'll try to answer without specifying them. Okay. What is partitioning in Spark? It's as it is a distributed computing environment. Each group of data will be partitioned. It will be considered as a separate partition, and it will store in a separate place. Divide data across nodes for parallel processing. Of course, that is partitioning. What is Parquet? Columnar storage format optimized for analytics. What is data skew? Uneven data distribution causing performance issues. What is the difference between pandas and Spark? Single machine pandas. PySpark is distributed. Okay. Transform raw data into feature engineering. Feature transform raw data into meaningful features of our ML. This is little difficult, but let's see. Final advice: Spark structured. Keep answers short. Use keywords scalable, distributed, optimized, reliable data quality. And it says I am ready for the interview. I am not sure until be a good understanding. Like there are some hiccups here, which is audio related stuff. Like once I give the response, the dictate thing is taking a bunch of a time, and sometimes it is not capturing the entire information as well. So that's where the drawback is right now. I hope I need to do some changes or some settings in this so that um, it will help to improve this more. So okay, as of now I'm gonna close this live, and thanks for watching. Please try to subscribe my channel. Thank you so much.